Let us look at Cauchy condensation test. Now, many series have terms that decrease too slowly for ratio, Rabe's, or root tests to decide convergence. In such cases, it is useful to group terms into blocks whose sizes double at each step. So the Cauchy condensation test converts the problem into a simpler series. Now, if you recollect, this technique of grouping into powers of two terms has already been used previously. The condensation test formalizes this idea. So, what does this test say? If the sequence of terms of the series U sub n is positive and non-increasing, then the series U sub n converges if and only if the series, which is the condensed form, converges. Okay, let's look at an example and understand this. So we have series U sub n is equal to the series as n goes from 2 to infinity of 1 by n times natural log of n to the power of p. Now, since natural log of 1 is equal to 0 and natural log n is in the denominator, the first term becomes undefined. And hence we drop the first term by taking n greater than or equal to 2. Now, the dyadic block, a block of size 2 to the power of k, where k is in natural numbers. That is, terms with indices in the interval 2 to the power of k, 2 to the power of k plus 1. Because U sub n is non-increasing, every term in this block satisfies U sub n is less than or equal to U sub 2 to the power of k. That is the first term. So every term of the block will be less than or equal to the first block. So the sum of this block is bounded above by 2 to the power of k times U sub 2 to the power of k. What is this? That is U sub 2 to the power of k times the number of terms, that is 2 to the power of k. So 2 to the power of k times U sub 2 to the power of k is equal to 2 to the power of k times 1 by 2 to the power of k times natural log of 2 to the power of k to the power of p. Simplifying this, 2 to the power of k to the power of k cancels out, and we have 1 by natural log of 2 to the power of k to the power of p. Using the logarithm rules, we bring k down. So we have 1 by k times natural log of 2 to the power of p, and which we can split it into 2. 1 by k to the power of p times natural log of 2 to the power of p. Now, natural log of 2 is a constant. So any power of that is also a constant, which means the condensed series has the same nature as the series 1 by k to the power of 2. The given series 1 by n times natural log of n to the power of p converges if and only if p is greater than 1. Why this condition? Because this is nothing but a p series. And we know that in p series, if p is greater than 1, then only it converges. We are applying that here to say that the given series converges if and only if p is greater than 1. So what is happening here? By taking block level view of the series, we are basically zooming out. Let's summarize this. Steps in this test: form blocks of 2 to the power of k terms, that is doubling each time, also called dyadic blocks. Each block forms a finite series. Study the kth block to figure out the upper and lower bound. Use the bounds to relate each block to a single representative term in the block, and apply the conclusion to the given series. That was Cauchy condensation test. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.